I'll hit record since y'all want to hear about the review questions. So go ahead. What is it? 8 million? Okay. Wait, hold on. If it's like significant whatever, like forget that question because we didn't learn that yet. We're gonna do that today.
That was
That was it? All right. All right, while you finding it, give me one. Like this? One parenthesis? Like that? Okay. Like that? Oh. All right. Okay. How do we do this? Exactly. Distribute that to everybody. Yep, that's it. So what's the first answer? 16x to the what? Very good. And the second one? 367, yep. What's the last one? That's it. Not bad, right? Yeah, that's it. That's the answer. Yeah.
What is that?
Yeah. Distributing.
Is it?
Can't remember what topic that was. Yeah. Mhm. Just distribute it. That's all. Yeah.
What is that?
The one that just opened last night. Yeah, we didn't get to that yet. But you will get to that though. That's coming. Yeah. But I'm happy y'all know how to do it. All right, go ahead. All right. So I heard negative 2a to the 9th power. Okay. Like one thing, like okay, b negative 5. Okay. C negative 3. Like this. Okay. 2 to the 8th power. Negative what? 4. Okay. That's not so bad. So how do I do this? So what does that become? So individually, but numbers with numbers, variables with variables. So negative 2 divided by negative 10 becomes what? Close. No. Mhm. All right, I was looking for y'all to tell me 1/5. Right? Because negative 2 goes into negative 2 once, negative 2 goes into negative 10 5 times, like that. All right. What about the next one, the A? What's that gonna be? 7? No. How do I divide powers? What do I do? No. Subtract, right? What do I subtract? Huh? The 9 minus the negative 2. So what's 9 minus negative 2? A negative and a negative becomes, right?
I knew you put that negative sign there.
Right? So 9 plus 2 is 11, right?
Yes.
This is 8 to 11, right?
Wait.
So A is 3 comes up.
It's gonna be on the top. Next, let's do the B. What's B gonna be? Minus what? Mm-hmm. What's the answer? No. Negative 13. Now we're talking. How about C? C is -3 minus -4, which becomes what? Oh, what is that? 1. Very good. All right. So let's put this all together, right? Remember, it's illegal for me to have negative exponents, right? So what does the b to the -13 become? No,
Oh,
exactly. Right? Then we have the c to the 1, and the a to the 11, and the 1 over 5. Let's put this all together. Remember that these are over 1. Putting it all together, I should have what? A to the 11, c over 5, b to the 13 power. So this would be my final answer right here. Hmm? Hmm.
so you can move forward. Okay, ready for it.
Yeah. How to answer that? Okay. So I have to do an open parentheses for the numerator first, right? And then we want another open parentheses, a raised to the 11 power, close parentheses. Then you can write your c, right? Then you want to close parentheses, divide, open parentheses, excuse me. Then you want to do your 5, open parentheses, b raised to the 13, close parentheses, like that. That's how you type it in. Mhm.
I think it tells you, like, if you.
It does. There's a hint. Yeah. Because you got to raise something to a power that has to get its own parentheses itself. And then your numerator and denominator needs individual parentheses as well. We're getting to that today.
Yeah, it's my work.
Yeah.
Look at this. I'm like, oh.
I got you.
It's my work.
Yeah.
Yeah.
So what about anybody else? Anybody have any other questions from the homework?
I think, but
Good. I got you. Yeah.
I got one.
Good. Oh, no, we gonna do that today, bro. We get into that. Yeah, yeah, yeah.
I got 5x plus 9 equals 3x plus 3.
5x plus 9
Oh,
equals 3x minus 3, right? And then we're trying to solve for x, right? All right, so what we want to do, I want to get all my x's on one side, all my numbers on the other, right? So I'm going to subtract 3x from over here. But remember, when I do the one side of the equation, I got to do the other side of the equation, right? The other side of the equal sign. So now 5x minus 3x, what is that? 2x plus 9 is equal to -3, right? Now I want to get rid of that 9, so what do I have to do? Subtract 9, very good. I want to do the one side, I got to do to the other. So now what do I have? I have 2x is equal to, what's this? -12, good. What do I do after that? Right, 2, very good. What I do to one side, do to the other. So I have x is equal to what? -6, right? And that's it. Because a negative over a positive is negative. Yeah.
Oh, that's right.
Yeah. Hmm?
So right there, whichever x.
Yeah, it doesn't matter. Yeah, you just got to be consistent. Yeah, 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 yeah. It's true. I'm trying to avoid the negatives. That's true. Yeah. But it doesn't matter. Whichever one you take is fine. Just be consistent. You do to one side, you do to the other. Yeah. Yeah, that's fine. That is, okay. All right, so anybody else, any homework questions? Anything? So we good? All right, go ahead. 18AB. Okay. Okay. And then what do I have to do with that? It's a S. Mm, It has what? I think, yeah. Yeah. You didn't do that one? Well, let's do your question because he's looking for it. Can you open up yours? Died. Gotcha. Mhm.
I got one. It's another.
Same thing like this? Gotcha. I think it's the solve for a specific variable, that one.
3x minus 1 equals -5. I thought it was just +1 both sides.
Just like this, it is that. Plus one, both sides. Right?
Divide by 3, right?
Wait, what's -5 plus one?
-4.
-4, and then divide by 3.
Get a decimal.
Nah, just -4 for 3. You can literally just type that in. Yeah.
That's great. Sitting here divide.
I mean, if y'all want, we could do it after class. You wanna do that? This one,
No, why?
huh?
Why?
Because we can't find out what the question's asking. Yeah. Yeah.
So, what is that? So it's somewhere in front of us.
Well, we're trying to figure out what variable they want.
But we don't know for which one.
It's the one that says solve for a specific variable. I'll tell you, it's homework. It might be. Let me check. Yep, 2.3. That's it.
All my questions changed.
Oh, they did? Mhm. Yeah. Change like the new, the different. What are they now?
So 1 plus 7 now.
Let me see. 10x minus 4yf. Like that?
That's fine.
Hello. Y? All right, that's not bad. All right.
This one is minus 10 by the L and minus 10.
Minus 10x, good. Minus 10x, right? Which you do to one side, you do to the other. So minus 4yf is equal to L minus 10x. And then what do you do after that?
So
For y, right? Not plus.
divide by
So divide by -4 and the f, right? And what we do to one side, we do to the other. And that's it. And then to type it in, right? You don't need the y equals. I'm just writing y equals, but y'all don't need that, right? Open parentheses, L minus 10x, close parentheses, divide, open parentheses, -4f, close parentheses. That's it. Right? This is that solve for a specific variable homework, right? All right, we all know how to do that. Let's pick up where we left off. I'm gonna try and run through this as quick as possible. It's not gonna be too bad though. So here's the next thing that we were about to get into, right? So we will now look at an expression containing a product that is raised to a power. So can you find this pattern? So we have 2x raised to the third power, right? We know that 2x to the third power means what? It means 2x times 2x times 2x, right? We're going to multiply all our numbers together. 2 times 2 times 2, that's 4 times 2, that's what, 8? And then we're going to multiply all of our x's together, which will give us x to the third, right? So how many factors of 2 and of x? We have 3. Do the math on that. You should have 8x to the third. So the exponent applies to each of the factors, right? That's the sauce right there. We got to remember. The exponent applies to each of the factors. And this is the product to the power property for exponents. No, we didn't do this. Yeah. I know y'all had it for homework. Y'all probably know how to do it already, but you just put a name to it, right? So anytime you have a monomial and it's being raised to a power, you're going to take the power and apply it to each of the factors on the inside. Everybody gets it, all the numbers, all the variables individually, right? So just to just to generalize this a little bit more, I appreciate that, man. 12 and a half, right? All right, so just to generalize it a little bit more, right? The product to a power property for exponents. If A and B are real numbers and M is a whole number, then A times B raised to the M power is the same as A to the M times B to the M power, right? So to raise a product to a power, you raise each factor to that power, right? Can't say that enough. To raise a product to a power, you raise each factor to that power. Really important. All right. Welcome, welcome, welcome. Let's take a look at this. Let's try this out. All right. That should be good. So I'm looking at A, all right? I have -3 times M times N raised to the third power. So what's going to happen here? Everybody, all the factors gets that third power, right? So this is going to be -3 to the third power times M to the third power times n to the third power, just like that. Just move this over here, right? And then just do the math the way you know how to do it, right? What's -3 to the third power? -27, very good. And then what's m to the third power? Exactly, m to the third power. And what's n to the third power? N to the third power, excellent. That's my answer, I'm done. Easy, right? I know y'all had this for homework already. All right, so what we have here, we have -4, a to the second, b raised to the 0 power, right? In the interest of time, real quick, somebody give me the answer. More. See, I love y'all. I love y'all. Woo! Yeah. Right? You had that one homework question, right? With A, B, C, D, E, and it was all, yeah. All right. So how about this? We have 6k. Let me try that again. K to the third power raised to the -2 power. What's going to happen here? Right? All of the factors are going to get that, right? So we have 6 to the -2, and then we're going to have times k to the third power raised to the -2 power, right? All right, somebody help me out. What is 6 to the -2 power? What does that become? Mm-mm. You're close though. What happens with negative exponents? What do I do? 1/36. Very good. Or 1/6 squared, which becomes 1/36. Very good. And then help me out. K to the third raised to the -2 power. What is that? That becomes k to the. When I raise a power to a power, no. When you raise a power to a power, you not add, multiply, right? So what does that become? Not 5. To the, you're close. -6. Now we're talking. But wait a minute, it's a negative power. What happens to it? Right. Becomes 1/k to the 6, just like this. Got you. And then we just multiply straight across. Final answer. 1/36 k to the 6 power. That's it. Questions on that? I know.
That is the way to do that.
Nah, that's the way this goes. Go ahead. Oh yeah, that's what I was about to grab. I didn't get it yet. Because of the cube. Remember, that's -3 times -3 times -3. Right, right, yeah. So let's look at D. So D. I have 5x. Hold on. 5x to the -3 power squared after that. What happens here? Right? Same thing. Every factor gets the power. Everybody. So help me out. What's 5 squared? Excellent. And then what is x to the -3 raised to the second power? What is that? X to the -6 power. Now you remember it's illegal for me to have negative exponents. So what happens here?
1/x.
Very good. So this is 25, 1/x to the 6. Let's put that together. They're being multiplied. This is going to become what? 25/x to the 6 power. Questions on that? Let me make it smaller because I realize like might be nice to just look at this together. Any questions on this?
Wait, what would 25?
Why the 25 did what? Oh, you know what I should have done with the 25 that I didn't do? I should have put it over 1. And then you can see that you're just multiplying straight across like that, right? Because remember, whenever we have whole numbers, we put it over 1 and multiply straight across.
But why you didn't do one over?
Because it's even. The two is an even power, not a negative power. The 3 is the one that has the negative on it. Yeah. So we good? We understand? Go ahead. Yeah. Mm-hmm. Mm-hmm. Sure. That's what it means.
Really?
Yeah, that's exactly what it means. Yeah. But the thing is that sometimes that power that is being raised to is too big. And we need a trick to get through it, right? So like, right. If when it's squared, like, all right, two of them next to each other, cool. But like, say that was like to the 8th power or the 9th. Now it's just like, oh man, I gotta write this out 9 times, Yeah. Yeah. Nah, that's it. That's the actual meaning of it. Yeah. All right. Well, everybody seemed like they getting it right. So let me let y'all try one. Make this a little bit harder. Put some W's and X's in there. Some P's and Q's and some A's and B's. All right. I'll even scroll up so y'all can see at least one example of what to do. So how late we staying tonight? 10, 11 o'clock? What y'all think? Down? Heard this week is gonna be mad hot. So yeah.
90 something.
Yeah. At least we get to like chill outside and then like when the sun is setting, we just be like, all right, let me go to class.
Hopefully the AC works.
Oh no, it's gonna be freezing in here. You're gonna see. We're gonna need jackets up in here. Everyone be like, why y'all wear jackets in class? Like, cause like
It's gonna be pretty easy.
um
They-
well the second one is really easy. I don't know about the first one. Matter of fact, to answer your question, you see how the first one A is to the 5th power? Like that's why we do these kind of tricks right here, because that's a lot. No? If everybody's good, we could try it out. Yeah, I need another minute. All right, let's take a look. So I got A, right? In A, what do we have? We have 2wx to the fifth power. What does that become? Okay, it probably is 32. 2 to the fifth, w to the fifth, x to the fifth, and you said that 2 to the fifth is 32? All right, I trust you. 32, w to the fifth, x to the fifth. Questions on that?
That's it?
That's it.
Well, no. Fraction.
Nope,
It's not negative.
it's not negative. What about B? What's the answer for B? 1. All right, I don't even want to write that out. That's a lot of work. So what is this? This is 2b to the third raised to the negative fourth power. What's this? Close. You close. 2 to the negative 4. And then you're going to have b to the third raised to the negative 4, right? And 2 to the negative 4 is what? You're close. 1 over 16. That sounds good. And then what about the b to the third to the negative 4? What does that become? 1 over what? B to the 12. Good, I like that. Right, put that all together. This becomes what? 1 over 16 B to the 12, right? Sound like vitamins over here. Okay. We good? All right, let's look at D. Not even gonna lie, I don't remember what D was. 8a to the negative 4. 8a to the negative 4, and I think that's squared. Let me verify real quick. Yep, it's squared. All right. The 12, 3 times negative 4. All right, give you negative 12. Yeah. Because whenever you raise a power to a power, you multiply the numbers. Negative 12, right? And then what do I do with the negative exponent? Right, you put it into the denominator and make the power positive. So that's how we get it like that, 1 over b to the 12. What about here? What happens here in D? That becomes what? A to the second times a to the negative 4 raised to the second. So what is this? A to the -8, right? It's illegal for me to have negative exponents, so it's a to the 8, right? Yeah, 64 over 1 over a, you're right. I should have wrote that. 64 over 1 times 1 over a to the 8th power, which becomes that. You don't have to. If you could see it, then go ahead and do it. Yeah, go ahead. When it's positive. Yeah. You see how it's 8, then that goes in the denominator. Yeah. All right. Any other questions? Are we good? Good. Go ahead. I'll make it smaller. Gotcha. Roscoe Brown. They should be open right now. They're not supposed to close till 7. Or is it 8 o'clock? I might be wrong. Huh? Really? Yeah. Yeah. I'm sorry. I'm sorry. I didn't even know that they was doing something like that. Tomorrow, I hope they're open. Wednesday, I know they're not open. No class. Juneteenth. So enjoy y'all day. Got you. Yeah.
It's like when the slaves were officially freed in the South.
Yeah.
Okay, so no, I've been to mad people, they don't know English.
When you come to school and you take like a Black Studies class, that's when you'll really learn the in-depth history of it. If you want.
Was it worth it for you?
I never took one.
Oh,
I didn't really know about it until it got popular and everybody was talking about it on TV and stuff. You know what it is? Like, to be totally transparent with you, Black Studies is like another English class. I'm a math person, you know? So like another English class means that's another book to read, another book report to write, and all that. I'm just like, if it was like take this class and we'll teach you about it and then that's it, and there was no papers or nothing attached to that, yeah, sure, I'd have been happy to do that. But when they say read this novel, give me this book report, I'm like, nah, I'm good. Like, yeah, like I mean, if it was that, okay, I got you, you know. But when you want the literary analysis and all of this, and I gotta, it's a lot. Like that to me, that's a lot of work. You know? All right, so let's take a look at this now. So now we will look at an example that will lead us to the quotient to a power property. So let's say I have x over y raised to the third power. I know y'all probably saw this on your homework, right? We know that this means x over y times x over y times x over y, which is simply put just x times x times x over y times y, or x to the third over y to the third. Notice that the exponent applies to both the numerator and the denominator. So we see that x over y to the third power is x to the third over y to the third. This leads us to the quotient to a power property, right? So what's key to remember here? The exponent applies to both the numerator and the denominator, right? And that's the quotient to a power property for exponents. Okay? I know most of y'all probably knocked out this on the homework already. Good job. Did mistake just there. So the quotient to a power property for exponents, if A and B are real numbers where B does not equal 0 and M is an integer, then A over B raised to the M power is equal to A to the M over B to the M. To raise a fraction to a power, you raise the numerator and denominator to that power, right? So this is key right here, this last sentence right here, right? To raise a fraction to a power, raise the numerator and denominator to that power.
Just restating the.
Yeah, the same thing, yeah. Let's try this out. Go ahead. All right, let's try this out. Probably not that bad. So let's say A, right? I have, whoops. Let me get my pen real quick. So for A, right? I have B over 3 raised to the 4th power. What's gonna happen? This is gonna become B to the 4th power over 3 to the 4th, which is what? I think it's 81. Y'all should check me. I don't know my timetables that well. Right? It's good. All right. So now I got you. How about this one? I have K over J to the -3 power. What happens there?
Oh, wait, you put it in part,
Mm,
1/k to the.
exactly.
1/k to. Oh.
Exactly. So the third, and this becomes 1/k to the 3rd over J to the 3rd. Help me out. Keep, change, flip, right? So what does that become? 1/1 times, right? J to the 3rd over K to the 3rd. So what's my final answer? J to the 3rd over K to the 3rd. Remember that, right? Keep, change, flip. All that good stuff. What about C? Let's change up my color now. I got 2xy to the 2nd over z is to the 3rd power. Who gets that power? Not just the y. Everybody, right?
The y is the second.
Everybody. Everybody gets the 3rd power.
I don't know, I'm talking about the second. The second, the y only gets rid. Where's that?
No, it gets the 3rd also. So look, it's gonna be, oops, 2 to the 3rd, x to the 3rd, y squared to the 3rd.
Okay, so that will go.
Over z, yeah, to the 3rd. Whoops. Right? Let's do the math on that. What's this, like 8? X to the 3rd, y to the what power? Y to the 6 over z to the 3rd. And that's it. Questions on it? Okay. Let's look at D. 4p to the -3. Over q squared. Squared. Let's verify, yep. So what do I do? Uh-huh.
Oh, because.
Right. Squared, squared. So 4 to the 2nd is 16. P to the, very good. And q to the
4.
Good. And remember, it's illegal for me to have negative exponents, so what happens to that p? Right, we're gonna flip it, so I'm gonna have 16 over q to the 4, right? Times, and then keep change flip, so, hold on. Thinking about that. I'm tempted to say should be 1 over p, yeah, to the 6, you're right. Multiply straight across, 16 q4 to 6, yep, that's it. Questions? I was gonna let you guys try.
She changed something where you a little bit.
Just change the p to the negative 6 to 1 over p to the 6 and then multiply instead. You guys try. Sorry?
You have to like simplify the.
Yeah. I mean, just doing a calculator.
To the lower.
Yeah, p to the 4 of it. Is it 100? I don't know. Is it 10,000? I trust you.
Four. That's. Oh. No, it's a four.
10,000, yeah.
Yeah. Then you make it right.
All right, let's take a look. A, what we got? I agree. Questions on that? Are we good? How about B? Very good. Questions on that?
Oh, it's not.
Right. But it flips.
The excellent was on.
So remember, keep, change, flip. So if you want to see this, right? It's gonna become, this is for B. It becomes 1 over the M over N to the 7 power. Right? Becomes 1 over M to the 7 over N to the 7. Sorry. And after that, what do we do? Keep, change, flip. 1 over 1 times N over 7 over M over 7. This becomes N to the 7 over M to the 7. Right? Keep, change, flip. Right? There is a rule that says that anytime you have a fraction raised to a negative power, you can just like flip them and make it positive. If you want to remember that rule, cool. If not, keep, change, flip. It always works. What about D? Wait, we didn't even do B. Hold on. What's the answer for B? Oh, C. My fault. My fault. I'm looking at C and I'm saying B. I'm sorry. What is it? B to the 4th? No. But C to the 8th? Yeah. B to the what? B to the 12th, right? Vitamins, vitamins. All right. How about D? What'd I do? Or what's the answer? Good. What else? X to the negative 6. What else? Very good. Remember, it's illegal for me to have. Uh-huh. 1 over X to the 6, right? And then final answer? X to the 6, Y to the 9. And then that's it. Doesn't matter. Because that's like, I'm sorry? Yeah. That's like saying if what is 3 times 2 versus what is 2 times 3. It's the same thing, it's just commutative. Yeah. We good? All right.
Oh, that's.
Uh-huh. Yes. So we now have several properties of exponents. Let's summarize them and then we will do some more examples which use more than one of the properties. All right. So this is that part of the class where you might want to take a picture, write it down. This is everything. This is the sauce. This is all put together. Everything that we did so far, right? So summary of exponent properties. If A and B are real numbers and M and N are integers, then there's a property and its description. Right? I'll make this a little bit smaller so we can see it all. Go. While y'all copy that, I'll take a minute and go get some water. I'll be right back. With this, you should be able to knock out.
Polynomials is simple in turn. Anything could be. No, class. Oh, yeah, that's
Yeah,
Monday.
yeah. Right back after.
Oh,
The other version of this class, the 28th, they got their final next week, Wednesday. Yeah. 3 weeks. Like, they just go fast, like mad fast.
Fast.
Yeah. They started the same day we started. All right, so we good with this?
I might have tried to sign me up for that, but I don't know.
Yeah.
It's like they're a little bit lax with the grading, but 3 weeks is crazy.
3 weeks is fast, like lightning fast. Like there's stuff that we get to like do here and like really explain that they just like, they'll just take my word for it. We gotta go. You know, it's that type of thing, you know? Yeah. All right, let's talk about the scientific notation. This is that second half of your homework right here, right? So we're gonna use scientific notation. Working with very large or very small numbers can be awkward since our number system is in base 10, right? We can use powers of 10 to rewrite very large or very small numbers to make them easier to work with. Consider the numbers 4,000 or 0.004. Using place value, we can rewrite the numbers 4,000 and 0.004. We know that 4,000 means 4 times 1,000, right? And 0.004 means 4 times 1 over 1,000, right? If we write the 1,000 as the power of 10 in exponent form, we can rewrite these numbers in this way. 4,000 is 4 times 1,000 or 4 times 10 to the third power, right? And 0.04 is 4 times 1 over 1,000 or 4 times 1 over 10 to the third power, which we know is 4 times 10 to the negative 3 power. So when a number is written as a product of two numbers, where the first factor is a number greater than or equal to 1, but less than 10, and the second factor is a power of 10 written in exponential form, it is said to be in scientific notation, right? Scientific notation. So long story short, what that means, right? This is key. The first factor is a number greater than or equal to 1. Got to do that. But less than 10. And the second factor is a power of 10 written in exponential form, right? That's scientific notation. So long story short, right? I'm gonna have some number here. This number is gonna be between 0. Excuse me, I'm wrong. Let me say that again. It's gonna be between 1 and 9. There's gonna be a decimal here. However many other numbers want to come after that, times 10 to some power that's going to be here. That power could be positive or negative. Positive meaning that it's a bigger number, negative is a smaller number. And that's it. This is something that you're going to see in your science classes a lot, right? You're going to deal with like really, really small things or really, really large things. I have to say things because different sciences are different, deal with different, stuff.
That's what science belongs. Started adding them to it.
Right? Started becoming precise. All right, so real quick, scientific notation, right? A number is expressed in scientific notation when it is of the form a times 10 to the n power, where 1 is less than or equal to the absolute value of n, which is less than 10, and n is an integer. All right, this is scientific notation. A little bit more background story right here. All right. Oops, 1 second. Sorry about that. All right. So it is customary in scientific notation to use as the x multiplication sign, even though we avoid using the sign elsewhere in algebra, right? So we like to use the x in scientific notation for multiplication, right? If we look at what happened to the decimal point, we can see a method to easily convert from decimal notation to scientific notation. So I have 4,000, right? If I move the decimal 3 spaces to the left, you see that that becomes 4 times 10 to the third, huh? That's positive, right? So that's like when I'm taking a big number, a large number, and I'm making it into scientific notation. Move the decimal to the left, right? If I have a small number, something real small, right, and I want to write that in scientific notation, I move that decimal place over to the right. So you see, I move the decimal place over 3 spaces, and then that's how I get 4 times 10 to the negative third power, right? So yeah, move the decimal point to 3 spaces to the left for the smaller, right? And then to the right when it's small, I'm gonna make it like that. So in both cases, the decimals move 3 places to get to the first factor, which is between 1 and 10. The power of 10 is positive when the number is larger than 1 to the 4,000, right? So 4 times 10 to the third, right? The power of 10 is negative when a number is between 0 and 1. So 0.004 is equal to 10 times, 4 times 10 to the negative third power. All right? And in a nutshell, that's what we're going to be playing with in our homework.
Saying that that's 7 different parts.
Mhm.
How do you write that?
So you move the decimal place over, right? Million, right? So 3, 6. So you're gonna move the decimal place over 6 times, right? And you're gonna get 7 point whatever you just said times 10 to the 6th power. That would be like 7 million.
You know that, though.
I don't know. So in my head, I'll show you. He said 7 million, but I don't remember. He said something real specific. I think it was 5.6,
Yeah.
something like that, right? All right. So like, let's say that this is like your first paycheck you're getting right out of college, right? So you want to write that in scientific notation. So you're gonna move the decimal place over 1, 2, 3, 4, 5, 6 spaces, right? The first number that I have here, it has to be a number that's between between 1 and I don't know why I keep saying 0. It's between 1 and 9, right? With a decimal point here, and then the rest of the numbers that you have there, which is the 5 and the 6, is going to come here, times 10 to the number of times I move this over, right? Which we said was 6, right? And then that's it. Where's the 1 to what? Oh, you mean like this comma here? That's just so I could tell that it's a million.
Oh.
Yeah. So like after 3 spaces, I put like a comma just to tell, kind of thing. Yeah. That's just my thing. You don't have to do that. If you want to write 75600, fine. You know? Real quick, before we get into like some examples real quick, I just want to give y'all like the sauce real quick, how to do it. All right. So this is how to convert a decimal to scientific notation, right? Step 1, move the decimal point so that the first factor is greater than or equal to 1 but less than 10, right? Step 2, count the number of decimal places you moved it, right? N, right? That the decimal point was moved, right? Step 3, write the number as a product with a power of 10. If the original number is greater than 1, the power of 10 will be 10 to the n power. If it's between 0 and 1, meaning it's a small number, right? It's going to be, the power of 10 will be 10 to the negative n power. And then they say step 4, check, but I trust y'all. Right? Let's take a look. I'm gonna start off real nice and simple real quick. So I got 37,000, right? That's what I'm starting off with for A, right? I have 37,000, right? Let's pretend I have a decimal point right here. And then I want to write this in scientific notation. So I'm going to move this over how many spaces? 1, 2, 3, and then 4. You're right. Right? 1, 2, 3, 4. Going to the left. So what's my number that I have here, right? This is going to be 3.7, right? Times 10 to the 4th power. Questions on that? Go ahead. I moved the decimal over four spots, right? And then so now the first number is something that's smaller than 10 but bigger than 1, right? So that's how I get the 3.7. I don't need to put the rest of the zeros, right? Zeros are not significant, right? The other numbers that are there are. And then times 10, right? That's always going to be there, times 10, raised to the number of times that I move the decimal place over to the left, right? To the left is positive, to the right is negative. That's it. Let's try B. Let's try B. So for B, I have 0.0052, right? I'm going to move this decimal place over right here. 1, 2, 3 times right here. Going this way. Right? So what do I have now? I have 5.2 times 10. Remember, that's the base. Now, how many spaces did I move over? I moved over 3, right? But I moved to the right, so that's going to be what? -3. And that's it. Questions on this?
So whenever it's like, that's the one thing, correct?
Yeah. Decimals are always to the right. Big numbers, always to the left. All right. You guys try. I don't know who I'm talking to, but I know that's somebody's yearly salary right now. I know that's definitely your yearly salary after BCC. For sure. And for B, we wish we could find a bank that had that interest rate. Oh my God. 7 pennies for $1,000. Can't find that nowhere. For the second one? 3 times. Because our first number got to be between 1 and 9. So it can't be like 0 point whatever. It's got to be like 7 point. All right, let's take a look. So the A, right? I got 96,000. Right? Decimal point is right here. I'm gonna write that in scientific notation. So I'll move this over 1, 2, 3, and then 4. This way. So this becomes what? 9. Mm-hmm. So it's right. Very good. Very good. How about B? A little bit harder. I got 0.0078. We'll move that decimal place over. 2, 3, right? 7.8. Excellent. Questions on that? We good? So as soon as I get to the first number that is smaller than 10, but bigger than 1 in between, that's where I know to stop. So I can't stop with a 0. I have to keep going till I get to a number that's not 0. That's the goal. Oh. Yeah. I can't stop at the in between a 6 and a 0, because 96 is bigger than 10. You know? So I have to go one more time now to get that first number to be smaller than 10. Yeah. That's it. All right, let's get into something fun. All right. So how can we convert from scientific notation now to decimal form? Let's look at 2 numbers written in scientific notation. So I have 9.12 times 10 to the fourth power. So that means 9.12 times 10,000, which is what? 91,200, right? Smaller number now, right? I have 9.12 times 10 to the negative fourth power, right? Which means what? 9.12 times 0.0001 or 0.000912, right? If we look at the location of the decimal point, we can see an easy method to convert a number from scientific notation to the decimal form, right? So look, 9.12 times 10 to the fourth is equal to 91,200. Start off with the 9.12, right? Move it over that number of decimal places, 1, 2, 3, 4. And that's how you get the 91,200. Same thing with the other side, right? I have the 9.12. I want to multiply that by 10 to the negative 4 power. Just move the decimal place over to the left 4 spots, 1, 2, 3, 4, and you get 0.00912. So as you can see, move the decimal place to the right, 4 places to the right to get the positive, 4 places to the left for the negative. If both cases the decimal point move, in both cases the decimal point moved 4 places. When the exponent was positive, the decimal moved to the right, and when the exponent was negative, decimal point moved to the left. All right. So that's our little trick. Real quick though, before we actually like get into an example, I just want to give y'all a little bit of procedure real quick. This is just a little how-to. All right, so how to convert scientific notation to decimal form. Step 1, determine the exponent n on the factor of 10. Step 2, move the decimal n places, adding zeros if needed, right? And then if the exponent is positive, move the decimal place of decimal point n places to the right. The decimal is negative, n places to the left. Step 3 is to check. Let's try this out. Let's try this out. All right. So I want to convert to decimal form 6.2 times 10 to the third power, right? We'll do A. So watch what I could do here. I have 6.2. And I'm going to multiply that by 10 to the third power, right? Easiest thing for me to do, take the decimal, move it over 3 spaces. 1, 2, 3. Right? Add on 2 zeros here. So what does that equal? 6,200. That's what 6.2 times 10 to the third is. Simple, right? Let's look at B. Let's look at B. I have negative 8.9 times 10 to the negative 2 power, right? So what am I gonna do, right? I have the, I have negative 8.9. I'm gonna move this over 2 spaces, 1, 2. So now add on a 0 here and a 0 here. What do I have as my final answer? This is negative 0.089. That's the answer for 2. Question. We good? All right, if y'all good, try this out. All right, try that out. right, let's take a look. So I have A 1.3. I'll move this over three spaces. 1, 2, 3. Add in some zeros. So what does that equal? 1,300. How about B? I have a negative 1.2. I'll move this four places over. So 1, 2, 3, and 4. Right, so add in some zeros here. What do I have? 0 0.123. 1.2.
Yes.
Yeah, this will become significant. Oh, sorry about that. That was my fault. Sorry about that. Questions on that? Then it would just be 1, 2, 3. So like it'd be 2 zeros in front. Yeah. No. Oh shoot. Yeah. My fault. Thank you. Yeah. Negative 0.0012. Yeah, because the question was negative. Right. Then it carries over. That's my fault. Should probably put one here too, right? That'll make more sense. All right, so we get the gist of this? All right. So when scientists perform calculations with very large or very small numbers, they use scientific notation. Scientific notation provides a way for the calculations to be done without writing a lot of zeros. We will see how the properties of exponents are used to multiply and divide numbers in scientific notation. Okay. Well, let's take a look. So this says multiply or divide as indicated. So let's look at A, right? I have -4 times 10 to the fifth power. Whoops, wrong one. Times 2 times 10 to the -7th power. What do I do here? I want my numbers with numbers, powers with powers. So -4 times 2 is what? -8 times 10. And what do I do with the numbers here, the powers? I'm multiplying them, so I'm going to do what to the powers? Add them, right? 5 plus -7 is? -2. That's my answer. Yeah. Well, wait, hold on. That's not my answer because they said they want the answer in decimal, right? So that means that I have to move this over, right? I have -8, right? Exactly. 1, 2. 0.08. Negative. Thank you. Thank you for that. Questions on that? Make sense? Numbers with numbers, 10 to the power with the 10 to the power. That's it. Let's take a look for B. I have 9 times 10 to the third power over 3 times 10 to the -2 power. All right. 9 over 3 becomes 3. Good. Times 10. Raise to what power? Not 1. What is it? So whenever I divide exponents, I subtract. So this becomes 3 minus -2, which is what? No, 10 to the 5th. Now we're talking. And that's it. Questions on that? All right. Mm-hmm. But of course, you know, I can't leave this in this question like that. Got to move that decimal place over 5. 1, 2, 3, 4, and 5. This is 0, 0, 0, 0, 0. So final answer, 300,000. Questions on that?
Whatever is divided,
Whatever is what?
whatever is divided,
Yeah, always. Right? Top minus bottom.
what is multiplication?
Multiplication, you add powers, right? Questions on this? Okay. Go ahead, try it. Got it? Not 5. 3 times 2. -6. Let's take a look. What do we have for A? You say it. And good. Let's put that in decimal. Right? 1, 2, 3. So this is negative 0.006. Good. How about B? 8 times 10 squared over 4 times 10 to negative 2. What do I have? 8 divided by 4 is times 10 to the, what is it? Positive 4, right? And then this becomes 2. We're gonna spot over 4 times. 1, 2, 3. 20,000, right? Oh no, 2,000. Oh, it's 4. My fault. You're right. 20,000. I like the comma. You don't got to do that. Your choice. Go
I
ahead.
did it backwards.
We're doing it backwards.
Like the positive, I was with support. Left.
No, positive is to the right.
Oh.
Like for a bigger number, negative is to the left. Yeah. 2 minus negative 2.
This something wrong, I don't know. I got
10 raised to the top minus the bottom. Right, and negative becomes positive. So 2 plus 2, 4. All right. Our homework shouldn't be harder than that. That's it in a nutshell. Multiply and divide. Let's talk about polynomials now. It's not so bad, I promise. Now that we know how to do all these with numbers, let's take it up a notch. Huh? Oh yeah, sure. Yeah. All right, I just want to start with a little blast from the past. How do I do this again? So we're going to distribute this 2. Excuse me. What's the answer? I'm impressed. Excuse me. Dang, this next one is hard. I ain't gonna lie. Help me out. What's A? 81, very good. What's B? 81. All right. What's C? Negative 81. Now we're talking. Questions on that? The B? Because B, right? This one's B, right? Negative 9 squared. This means negative 9 times negative 9. Right, and negative is positive, and then 9 times 9, 81, like that. But for C, right? C means negative 1 times 9 times 9, which is a negative 81. Right? The parentheses thing, that thing matters. That's what it is. Right. But for C, it's -1 times 9 times 9. Should be -1. All right. I know this is somebody's homework question in here that's about to come up. How I do this? Plug it in, right? This is 2 times -2 squared minus 5 times -2 plus 3. Oh, what's the answer? 2 times, what's that? No, not -4, that's +4, right? Minus 5 times -2 plus 3. And what's 2 times 4? 8. And -5 times -2 is +10.
It's fair.
Right.
Yeah.
Plus 3. What's my answer? 21, right? Very good card game. Yeah. Let's go blackjack. I feel like somebody asked me this question earlier. And here's the explanation of how to do one of the questions from earlier. So we're gonna be multiplying monomials, right? I'm just gonna start off with this first. So we are ready to perform operations on polynomials. Since monomials are algebraic expressions, we can use the properties of exponents to multiply monomials, right? Let's take a look at what that is. I'm sure you guys seen it in the homework already, so you're not surprised. This is multiplying the monomials, right? Once again, right? Let's say for A, I have 3x squared times -4x cubed. Remember, numbers with numbers, variables with variables. So what's 3 times -4? -12. And x to the second times x to the third is x to the, not the 6, x to the 5th, right? So when we multiply the powers, we add them, right? How about B? I'm just gonna change up my color real quick. All right, I have 5/6 x to the third y times 12 xy to the second power, right? So help me out. Numbers with numbers, variables with variables. So 5/6 times 12 is what? 10, right? So 5/6 times 12/1, right? Okay. There's my mouse. Okay. Yeah. 1, 2, so that's 10. How about the x's, right? X to the third times x is x to the fourth. And y to the first times y to the second is y to the third. That's my answer. I'm done. Questions on this? Remember, numbers with numbers, variables with variables, right? Mhm. You guys try. After this lesson, you might be able to complete all your homework. I don't think I'm gonna finish the lesson for today. We're gonna have to continue most of this tomorrow. Which is fine though. Yeah, homework is open if y'all wanna take a look. It wouldn't surprise me if you're able to do it. That's, that's the 5.3. I'll tell you in a minute. Yeah, that's the 5.3. Yeah, you probably know how to do it already, so. Yeah. All right, let's take a look. So remember, numbers with numbers, variables with variables, right? 5 times -7 is what? -35. Y to the 11, good. And what about B?
Six. A.
6A to the 5th, what? B to the 6. If you want to, yeah. So that would be like 2/5 times 15/1. 5 goes into 5 once, 5 goes into 15 3 times, right? So 2 times 3 is 6/1, which is just 6. Yeah, yeah. We good? Make sense? Numbers with numbers, variables with variables, right? All right. So which one? A to the 5th. So I have A to the 4th times A to the 1. Remember when we multiply the powers, we're gonna add them, right? So that's gonna be A to the 5th. Same thing with the B to the 3rd times B to the 3rd. We're just adding the 3 plus 3 to get 6. That's it. So let's take a look at this one. We want to multiply a polynomial by a monomial, right? So multiplying a polynomial by a monomial is really just applying the distributive property, which we all know how to do already, right? Nothing new here. Nothing new here. So let's just take a look at it. Real simple, real simple. All right? So for A, all right? -2y times 4y squared plus 3y minus 5, right? What am I gonna do with that? Distribute it. That's it. Distribute, distribute, distribute. That's the end of the whole problem. -2y times 4y squared becomes what? To the 3rd. Very good. -2y times +3y becomes to the what? To the 2nd, right? Because 1 and 1.
Oh.
Right? Now -2y times -5 becomes +10 what? 10y. Good. That's my answer. I'm done. That's it. Nope. Just distribute. That's the end of it. All right. All right. Let's do something a little bit harder. Let's look at B. All right. So for B now, right? I have 3 x to the third power times y times x squared minus 8xy plus y squared, right? Same game, just distribute. Boom, 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 right? So what do I have? What's my answer? 3x to the third times y times x squared. What does that become? I'm gonna erase these arrows because that's it. 3x to the fifth y, very good. A positive times a negative is a negative, and 3x to the third y times 8xy becomes 24, x to the fourth, y to the second, very good. Now 3x cubed y times y to the second becomes what? Very good. And that's it. That's my answer. I'm done. We good? All right. You guys try. I think y'all might have enough knowledge to knock out y'all homework, but there is more to cover in this section. We're trying to figure out how to multiply a polynomial by a polynomial, but we're starting off simple, right? We got the monomials, we're just multiplying two of them. Now we're multiplying a monomial with a polynomial. What y'all think comes after a monomial? Monomial means one, so what comes after one? Binomial, right? So we're gonna be doing that. But you're never gonna guess the technique of how we do that. We distribute, same thing, all over again. All right, let's take a look. So for A, right? What do we have? Negative 15y to the third. What else? Minus y squared, I agree. Plus. Excellent. That's my answer. How about B? What we got? Very good. Uh-huh. Good. Very good. Questions on that? The powers. So whenever you multiply exponents, you add the powers, right? So I have negative 3y, right? And I multiply it times the first term here. This is y to the first power, right? So y to the first times y to the second becomes y to the third. Just add it, right? The next one, y, it's 2, yeah. And the other one didn't have a y, so you just put the y there. That's it. All right. So we good? All right, let's take it up a notch. This one I know y'all definitely remember from high school. Now multiply a binomial by a binomial. Just like there are different ways to represent multiplication of numbers, there are several methods that can be used to multiply a binomial times a binomial. And we will start by using a distributive property. All right. I know y'all remember this, right? Nothing new here. What is it? Y squared what? Keep going. Not 14, look.
No, I said 40.
Boom, boom. 8y, right?
5y.
Plus 40, very good. And then you want to combine like terms, right? So this becomes what? Y squared plus, what's 8 plus 5 again? 13y plus 40. I think I'm joking. I really don't know. Right? So now, how about B? Boom. Right? 4y times 2y, what's that? 8y squared, very good. And then now I have 4y times negative 5, what's that? So close. Negative 20y, very good. I'm gonna just pull this over a little bit because of space. All right. Then I have 3 times 2y, what's that? Plus 6y. And then I got 3 times negative 5, what's that? No, negative 15. Now we're talking, right? And then what I want to do after that, I want to combine like terms. So what do I have? No. So 8y squared, and then negative 20 plus 6 is negative 14y minus 15. That's my answer. Remember this, right? A little bit? All right. This was definitely in high school right here. We got this one. It's the bomb. Like make it smaller?
Yeah. All right, there you go. Good. You guys try. Hold on a second. Bless you. All right, let's take a look. What's the answer for A? Plus what? That might be right.
Oh, that's right. Yeah.
Let me think. Yeah, that's good. How about B? Very good. Positive 14C. Let's see. Let me think about that. Good job. 17? All right, let's take a look. So for A, right? I gotta distribute these. So first thing I want to do, x times x, right? That's gonna give me my x squared. The next thing I want to do, x times 9, that's gonna give me my positive 9x. Then I want to do 8 times x, which is gonna give me my positive 8x. And then I want to do 8 times 9, which is gonna give me a positive, what, 72. And then the 9x plus the 8x, right? That's the 17. Yeah, so that's how that comes. Questions on that? All right, come sign attendance. I have more to do, but we'll finish it up tomorrow. Oh, all right.
Space.
Yeah, come through. I mean, even if like you can't make the appointment, just walk through. Yeah, that's fine. Yeah, that's fine. So yeah, stay on top of your homework, guys. Like, please finish up. We have till Thursday afternoon. Yeah, yeah, that's no problem. You can actually email me through WebWork, like on the individual question, you just click email and then just like say like, oh, how to do this or whatever. Yeah, yeah. Like in the WebWork itself, I'm saying, you can just email me from there. No problem. How you doing? Got you. Sorry. Go for the homework. For the homework and stuff? So do you know how to log into Brightspace? Have you been getting the messages on Brightspace and all that? All right, let's work on that. That's what we gotta do today. All the stuff is there, how to log in for the homework, how to the recordings, because I actually record the class so you can rewatch all the stuff. All that. And sign the attendance also when you get a chance. So yeah, how are you? Good? Good. Yeah. So when you scroll down, that's the class right there.
Okay.
Just click there, like go to where it says announcements, and then you'll see everything there. You can go from like the first announcement up.
Okay.
Yeah, so it tells you how to log in to get to the homework, the link for the homework and all that. It also where tutoring is. You're welcome to do tutoring. It's online and in person, so whatever is best for you. Online is every day. Except, you see, man, all right, online is every day, 7 days a week, but in person though, is only Monday through Friday for this month,
Okay.
yeah. And it's on the same time, 12 to 6. Recommend. Yeah. All right, you're welcome. Yeah, email me if you have any questions or anything, all right? Yeah. So, man. You guys are done copying? Good?
Take care. Have a good night.
You too, man. Thanks, man. See you. Good? You good at copying?
Yeah.
All right, good, good.
Well, that guy's
I
had a
wanna,
rough couple life.
Yeah,
And it's triggers.
right?